Hey everyone, in this video I'm going to walk you through lab 710. In this lab we're going to do a diagnostic analytic to examine whether or not there is a relationship between advertising and sales. If we spend money as a company on advertising our products, does that translate into sales dollars for us? Okay, so we have a data set here that gives us month, right? The month of the year, the actual specific date within the month, the amount of advertising expenditure, and then revenue. And the first approach to determining whether or not we have some type of relationship between advertising and revenues is just to look at this data in what we call a scatter plot. So a scatter plot will have an X and Y axis, and it'll put dots within the graph that represent the combinations of different advertising and revenue amounts. All right, so we're just going to highlight cells C and D, or I'm sorry, columns C and D, and we're going to insert. We'll go to charts here, and we're going to do scatter plot. And we have a nice looking scatter plot here, but we want to see, we want to add like a trend line here to see if there's some type of relationship. So I think we want style. There's one of these that gives you a trend line. And let's see. Quick layout, maybe it's, there it is. So if we go to quick layout here, under the chart design tab, this will give us a scatter plot that also has a regression line added to it to show that there's show whether or not there's a relationship. Okay, so I'm going to talk to you in a second about how to read this chart. So, but first, before I do that, I want to just give titles to these axes. So the x-axis here is advertising expenditures. So advertising expense, and then this axis is revenue. All right. So it looks like there is some relationship. It looks like just visually, and I'm not saying that I've tested this, but just using my own eyes, it does appear that there is some type of relationship between advertising spend and revenue generation. And Excel added this regression line. So a regression line, what it's designed to do is to approximate the relationship between the x variable and the y variable. And it takes that Algebra 1 formula for a line, where Algebra 1 you learned the formula for a line is y equals mx, m times x plus b. Right? And then if you remember, the m was the slope, and you said m is equal to y2, data point y2 minus data point y1 divided by x2 minus x1. Right? That's all we're doing here. We're saying, our y variable is revenues, and our x variable is advertising expenditures. And Excel is trying to calculate a line in this format in a way, it's not going to be perfect, right? This isn't going to be a perfect relationship between expense and revenues, advertising expense and revenues. So Excel is going to calculate this line in a way that the distance from each data point to the line is minimized. So we're going to draw a perfect line so that if you add up all the individual distances from these data points from the line, the distance is as low as it possibly can be. That's what regression does. Okay, so this is called ordinary least squared regression. All right, and the least squared part is the way the line is drawn is it minimizes the squared distances from each data point to the line. All right, so visually, this tells us that there probably is some type of relationship here, but we need to test this statistically. Okay, so the next thing I want to do is I want to zoom out and I'm just going to actually tell Excel to give me the regression estimates. So I'm going to say we'll go to our data tab, right, and we're going to say data analysis. And in a previous exercise, I walked you through how to install the data analysis toolkit that I'm using here, and if you need that, just email me and I can send you the video on how to install that. But we're going to go to data analysis and we're going to want to do a regression, and it's asking us, alright, what is your y variable? What is your dependent variable? And so our y variable is coming from cells D1 through D37. Our x variable is coming from the advertising expense C1 to C37. The first row in those columns is it represents our data labels. So we're going to click OK. We have everything, all the options that we want. They're selected. We're going to click OK. And then it outputs our regression results in a new worksheet. Couple things to look at here. We want to look at how well the model works, because we might have just, we might be examining something where there's absolutely no relationship, and so then the model would not work at all. The test statistics to see if the model worked. First here is the F statistic. This has a p-value of 0.0007. That's very small. That's a good statistic. Low p-values are good, so it looks like the model worked. We could also look at adjusted R-squared. This measures how well the x variable here explains the variance in the y variable. So this is another measure of how well the model works. We get a p-value of 0.266. That's a very good. I'm sorry, not a p-value. An R-squared value of 0.266. That's a very good R-squared value. So we're happy with the model. Looks like it's working. Next thing we want to look at is advertising expenses. This is our x variable. The coefficient here is 3.677. It looks like there's a positive relationship between advertising expense and revenue. And if we look at the significance of this, the p-value here is 0.0007. That, again, that's very low. That's a good p-value. That's indicating to us that we can reject the null hypothesis that there is no relationship between advertising expense and revenue, and we can accept the alternative hypothesis that there is some relationship between between advertising expense and revenue. What this is saying here, because the units for both advertising and revenue are dollars, what this is saying is for every dollar of advertising that we spend, we're going to generate approximately $3.68 of revenue. Okay, and if we wanted to, we could calculate the predicted revenue. Right, so we could say predicted revenue would be the intercept, right? So this is y equals mx plus b, right? So let's just set it up that way. We're using this formula, right? So we're going to say predicted revenue is equal to m, our slope, which is the advertising expense, times the x value, which is advertising expense here, right? So we're going to take our slope multiplied by our x value plus our intercept, our b value, right here. And so then our predicted revenue would be, let's format this the same, $1,010,000. So our predicted revenue for this amount of advertising expenditures would be $1,010,000. Our actual revenue was $1 million. Okay, so pretty close. We can calculate, or I'm sorry, let's put absolute references in here. Let's do, we'll do F4 here, we'll do F4 here, and then this should work if I copy this down. So if I just do double click here, let's see what's the problem now. Oh, we don't want the sheet 2. We don't need this. Oh, we need an absolute reference there. Oops, I'm going to do F4 again, right? So we'll do that. Now this works. Let's see. And it's looking like we don't want an absolute. I made a mistake here, so let's take the dollar signs off of this. Okay, there we go. All right, this should work now. One last try. All right, there we go. All right, so now we have our predicted revenue for each of these advertising expenditure amounts. And so that's essentially this is how you calculate the regression line. This is where the regression line is coming from. So if you so this concludes our walkthrough of Lab 710. Hopefully you found this useful, and I will talk to you soon. Good luck.